Passwords aren't the only way to log in. With Wallet Sign-In, a user proves control of a blockchain address by signing a fresh message from the server. The app verifies that proof, prevents replay, and starts a familiar web session. Everything so far has led here: blockchains, authentication, keys, wallets, and message signatures. In this module, we'll connect them into one practical, passwordless sign-in flow for real web applications. Traditional login asks, "Do you know the password?" Wallet login asks, "Can you prove you control this address?" The app sends a unique message, often called a nonce. The wallet signs it with the private key, but that key never leaves the wallet. The server checks the signature against the public address. If the math matches, ownership is proven, and the app can issue a normal session token. This flow works because each actor has a narrow job. The user starts the login and approves the signing request. The wallet protects the private key and creates the signature. The frontend coordinates the experience. It asks the backend for a challenge, sends it to the wallet, then returns the signed result. The backend is the authority. It creates the nonce, verifies the signature, maps the wallet to a user, and establishes the session. The key security step happens before signing. The frontend connects to the wallet only to learn the public address, then sends that address to the backend. The backend creates a fresh nonce for this specific login attempt and builds the challenge message around it. That message should also name the app domain, the requested action, and an expiration time. Because the server generates the nonce, attackers cannot reuse an old signature as a valid login. Think of the nonce as a one-time ticket for a single sign-in attempt. The backend generates it randomly, includes it in the challenge, and records that it is valid only for this request. When the user signs, the signature covers both the nonce and the intent to sign in. If someone tries to replay that signature later, the server rejects it because the nonce was already used or has expired. A wallet signature should read like a clear login request, not a mystery transaction. Include the application domain, a plain sentence such as "sign in to example app," and the user's wallet address. Add a unique nonce, issued time, and expiration time so the signature cannot be replayed later or reused elsewhere. This is the idea behind sign-in with Ethereum EIP 4361. Make authentication specific, time-bound, and understandable. Once the frontend has the challenge, it asks the wallet to sign that exact message. The wallet pauses the flow and shows the user what is being signed, so this is the moment to read carefully. If the user approves, the wallet creates the digital signature locally with the private key. No blockchain transaction is sent, and usually no gas is paid. The app receives only the signature and forwards it to the backend for verification. Verification is the backend's trust-critical job. It receives the claimed wallet address, the original challenge message, and the signature. Using the message and signature, it recovers the address that actually signed. If the recovered address matches the address tied to the login challenge, authentication can continue. If it does not match, the request is rejected. This check belongs on the backend, because front-end-only verification can be bypassed. After the signature is verified, the backend can trust that the signer controls that wallet address. The next step is mapping the address into the application's user model. The simplest approach is wallet as user. If the address is new, create an account. If it already exists, sign that user in. More mature products often link wallets to profiles and may support multiple wallets, but only with clear rules to prevent accidental account takeover. Once the login proof has done its job, the app should return to normal web authentication. The server looks up or creates the user, then issues application state, usually a secure, HTTP-only session cookie, or sometimes a JWT. Users should not have to sign every protected request. Future requests simply present the session or token, and the backend checks it before allowing access. With JWTs, expiration and storage need extra care. Replay attacks exploit a simple mistake, treating an old valid signature as if it proves a new intent. If an attacker captures a signed login message, they can submit that same payload again, unless the backend tracks whether the nonce was already used or has expired. The signature may still verify cryptographically, but the session request should fail. Secure login checks both authenticity and freshness, so every attempt is unique and single-use. A nonce is not just a random string. Treat it like a short-lived backend record tied to one login attempt. Store the nonce, wallet address, issued time, expiration time, and current status. When the signature verifies, immediately mark that record as used, so the same signature cannot be replayed. If the expiration time passes, reject it automatically. The key rule is simple. The backend is the source of truth, never the front end. A reliable wallet sign-in flow comes down to a few checks. The server creates a unique, short-lived nonce for one login attempt. The user signs a clear message that names the domain, wallet address, nonce, issue time, and expiry. The backend verifies the signature and confirms it matches the expected address. After success, it invalidates the nonce immediately and creates the session securely. Never reuse challenges, and never trust verification done only in the browser. Wallet sign-in turns cryptographic ownership into a familiar login session. The user signs a clear, nonce-based challenge. The backend verifies the signature, links the wallet, and invalidates the nonce to stop replay. Next, we'll connect this flow to traditional web apps, account linking, and existing authentication systems.